Hi, everybody, and welcome back. Today, we're going to be talking about absolute value. So for today's example, there's a number line here, but we're going to make this number line come to life. That way, we're keeping with our promise of making sure that math is always applied. So we're actually going to be talking about Mr. Reardon and Mr. Hinklin today. So fun fact, I am recording this video from a closet in the Powerline lab, and the closet's actually behind the office that Mr. Hinklin is in. So I'm going to say that we represent, let's say, -4 on the number line here. So Mr. Reardon and Mr. Hinklin, little office and closet space. And if they walk about 0.2 of a mile, they'll make it all the way to the academic space. So we'll put that all the way on the other side of our number line here. So academic space. And somewhere in between, we're going to have, probably the commons they're a little bit closer to academic. So I'd say that maybe they're about 1 or so. So if you're not familiar with the Career Center, you'll know that I'll just a quick explanation. So Powerline Lab is like the furthest, closest to where you pull into the parking lot possible. And then if you walk all the way basically to the other side of the building, you're going to see academics there. So quite a big walk. And basically that's how we're going to understand distance today. So we'll call 0 the main office. And what we want to think about is what's the different distance to the main office. So the main office is for the teachers. Fun fact, if you don't know this, that's where we sign in and sign out every day. They take our attendance there. So every morning when I come in, I have to take my attendance at the main office. And every day when I leave, I also have to go to the main office. So why this matters to me is because I have to walk from my glorious closet to the main office before I want to leave, and I have to walk from the main office to my closet once I get started for the day. So I can't just like enter from the side of the building. No, I have to go all the way back to that distance. So we can think about this in a way that measures that distance. So I am starting at -4 here, but I'm walking to 0. So the distance that I walk, we'll call that 4. So the distance from Mr. R to the office is 4. Okay, so I have to take 1, 2, 3, 4 jumps to bring me there. All right, so what about, let's say another academic teacher that doesn't have to teach from an office or a closet in the Powerline lab, let's say Mr. Carpenter. So he's in academics, he also has to go to the main office to sign out every day. So we'll do him in green. So he starts off at academics, he takes 1, 2, 3, 4 jumps, and he is at the main office. So we'll say Mr. Carpenter to the office is also 4 away. All right, so maybe I don't have so much of a reason to complain if he has to walk 4 and I also have to walk 4. So we're thinking about this in terms of distance. So we're not really thinking about signs right now. We're literally just thinking about what is my distance to the main office? What is my distance to 0? The skill that we're going to be covering today is called absolute value. And absolute value is kind of the same idea. Absolute value does not care about your sign. It just cares about your distance to 0. So that's going to kind of ground how we're thinking today. Is we're not necessarily thinking, oh, Mr. Reardon is -4 away from the main office. We're saying that Mr. Reardon is 4 jumps away from getting to the main office on this power line, on this number line here, excuse me. So with that as our grounding example, let's actually move forward and let's define absolute value. So absolute value is our vocab term. So if you could, please write that into our model. And absolute value is defined as a number's distance from 0. On a number line. I'll be even more specific. We'll say on a number line. So every single time we're thinking about absolute value, we're just thinking about the number line and how far away is the given value from 0. So let's say if we're taking the absolute value, and that's how we write it, just those 2 straight bars on the side. So not parentheses, they're not curved, they're just straight bars here. -6. So -6 is distance from 0. Well, to get from -6 to 0, we take 6 jumps, and we're there. So it's just 6. So it's 6 away from 0. Again, not concentrating on that these are negative jumps in a positive direction or negative direction. None of that matters to us. We just care about how many physical jumps are we taking, how far away is it from 0. So what about a positive number like 8? How many jumps away is 8 from 0? Well, if we take our big jumps, we're going to see it's going to be 8 individual jumps from 0. So again, it takes 8 to get from 8 to 0. So nothing changes there, still positive. So the answer to all of our absolute values, no matter positive or negative, inside, so inside doesn't matter, the sign, our answer is always going to be positive. So I'll say that one more time. The answer to an absolute value will always be positive. All right, so it doesn't seem so bad. It's just like, hey, what's the absolute value? -6? +6. What about +6? Oh, still +6. Those are quick examples, right? We can solve those without even doing any calculation at all. So how does this apply to Algebra 2? Well, you're going to see absolute value signs in more complex equations. So some steps for solving when you see absolute value signs. So first, isolate the absolute value. All that means, I know isolate's a big word to use there, is just get it alone. Get it on one side of that seesaw. So like we talked about the elephant and the mouse the other day, it's just making sure the elephant is alone. Okay, so if you see an absolute value somewhere, get it alone on that one side of the equation. Next, we're going to set it equal to the positive and negative values. So a quick intuitive explanation of that step is just, it doesn't matter if it's negative or positive inside of the equation, it's going to give us the same answer. That's what we're going to apply to solving an equation, is that the value on the inside, doesn't matter if it's negative or positive, we'll still have that same value on the outside. So we actually have to solve for both. We can't just give a positive answer, we have to give both positive and negative values there. And then finally, isolate your variable. An important thing to note, and I wrote this down in the steps too, is that you're always going to have two answers for these. Again, it might not necessarily be a positive value of your variable, but it will be a positive value inside and a negative value on the inside. All right, so number one. First, isolate the absolute value. We're going to see in our equation, we'll draw our nice algebra line here so we can clearly mark which side is which. On the left side, it's actually just the absolute value. And again, we're going to see the absolute value symbols. I'll draw little arrows to them here. So that's it. So step one is already done for us. All right, so step two. We have to set our equation equal to both the positive and negative values here. So it looks like actually, I don't actually have to do any algebraic work quite yet. I have to separate myself out into two equations. So we have 3x plus 2 equals our positive value, which is 1. And 3x plus 2 equals our negative value, which is -1. So I'll say that one more time. So initially, we got to make sure the absolute value is alone on the left side. We actually didn't have to do that because it was already done for us. It was already alone. So my step two is setting equal to, and I'm drawing arrows here again, to positive and negative values. So I'm taking everything on that right side of the equation and making it positive, or in this case, negative for the other side. Okay. And again, two answers, and I have two equations to solve for. So I'm going to divide these out. Again, work organization is so important, especially if we have multiple answers coming through here. So left side, let's solve. So now I can draw my algebra line down. I have my constant. The inverse of positive 2 is -2, so I'm left with 3x equals -1. So x equals, again, 3 times x, the inverse here, divide, x equals -1/3. And I am okay with that. So you can leave it as -1/3. Next, same thing. Okay, positive 2, the inverse again, -2, -2. 3x equals, and check yourself right here. So we start off at -1 on our number line, and we have -2. So we're actually going 2 jumps to the left. So that's going to be -3. So -1 minus 2 is -3. It's not 1, it's not positive 1, it's -3. We're starting with a negative number, we're making it 2 more negative, so it's going to be a bigger negative number, -3. All right, last step here, 3 times x, inverse of times, it's going to be division again. So we're left with x equals -1. So we have two answers here. X equals -1/3 and x equals -1. All right, a quick note. Let's just check to see, is Mr. Reardon lying? Does this actually work? So up in the top left here, you'll see me drawing this in 3 times -1 plus 2 in the absolute value sign. So let's do this. So -3 plus 2 is -1. The absolute value of -1 is in fact 1. Okay, so I know that this answer is good. So all I did there is I took my x value and I just plugged it in to see, does it equal what we want it to? All right, so now let's try my second solution here. 3, the absolute value of 3 times -1/3 plus 2. Okay, 3 times -1/3. Okay, so that's -3/3, -1 plus 2. Again, the absolute value of this -1 plus 2 is +1. So the absolute value of +1 is 1. Awesome. Both of these work. And again, we're seeing we have our negative and our positive answers here. So I followed my steps. I got my 2 answers. Both of my 2 answers here are correct. So again, this is why I love the balance and equation solving side of algebra. You can always plug back in your values and see if you're right. So if you're on a test, you're like, gosh, I forgot what Mr. Reardon said. Try a couple different answers. Try plugging them back in, and you'll be able to see, did you or did you not get it? All right, second example. This work is a little bit more tricky. So let's jump in. So step 1, isolate the absolute value. So absolute value and then a +7. Oh gosh, it's not isolated. So what that means is that we do have to do a little bit of algebra before we can go forward. So algebra line to start, keep myself organized. -7, -7. Again, I am eliminating that constant. I'm doing the opposite inverse operation here. So 7 minus 7 is 0 on both sides actually here. So we get 0. And then on the left, 3x plus 12 and the absolute value of that. Okay, step 2, set your equation equal to the positive and negative values. All right, so let's do that. So we have 3x plus 12 equals +0, and then 3x plus 12 equals -0. Well, positive and -0 are the same thing. So this works out in our case, right? So this actually isn't too bad of an example. If this was equal to a different number, yes, you're definitely going to want to set it like, say, equal to positive and -2, if that's what it was equal to. But in this case, it's 0. Save ourselves a little bit of time, and we can just go ahead and solve this. So -12 on both sides, 0, -12. So we start off at 0, and we take -12 jumps. So it's going to be, again, -12, not +12 here. So 3x equals -12. Divide, because it's 3 times x. The opposite of times x is division. So again, divide by 3, divide by 3. So x equals -4. And if I did set this equal to positive and -0, we just see it'd be the same answer. So my 2 answers here are actually just -4. And again, we're not going to repeat it, but it'd be -4 again. So in this case, because 0 is just 0, right? There is no distance from 0 to 0 on the number line. It's just 0. We're going to have just one answer in this case. So a good tricky example for you in case that comes up. But again, setting it equal step 2 to positive and negative values, and then we're isolating our variable, so we get x equals 4 as our solution here. Again, you can plug that in to see, did that or did that not just work? And that's what we are looking at. All right. So before we go on, we're going to have one more quick example. It's going to be a special example for us here. And what the special example is going to be is, again, another trick type question. So if we see these on standardized tests, SAT, ACT, anything like that, they might give you some of the more straightforward ones, but knowing that standardized tests are terrible things, they try to confuse you and give you the most difficult examples. We're going to go into a special difficult example. All right, so step 1, same thing. I have a constant. I need to eliminate my constant. So -7 on both sides. Okay, so that leaves me with 0 and then -5. Again, start off at +2. 7 negative jumps to the left gives us that negative number, so we're left with the absolute value of 3x minus 7 equals -5. Now, before I go on, I want to think about this conceptually. We have an absolute value equals a negative number. Is that possible? Based off of the definition of an absolute value, it is not. It's just the distance from 0. It's not a negative value. It's the positive distance from 0. So no matter how we look at it, even if we make 5 jumps to get to 0, we're going to measure that as 5 positive jumps. So there is no way for an absolute value to equal a negative number. So we're going to say this, I'll be really clear. Absolute value cannot equal a negative number. Okay, so in this case, there is no solution. There is no possible value that we can plug in for x that will make an absolute value negative. This is impossible. Can't be done. Okay, so I just wanted to throw this in there in case this came up as an example. And again, sometimes you'll see it, but I just want to make sure that concept is really clearly hitting home here. An absolute value cannot be negative. All right, that's the big idea for today. What you're going to see is, again, with these absolute value equations, it is going to be some review of 1.1, because after you set it equal to your positive and negative values, it's just solving equations. So this ties in really nicely to the skill that we did right before this. And again, the only major difference is that after isolating that absolute value, we're setting it equal to positive and negative, and then it's just basically just going ahead and solving equations. So think about my closet, think about me and Mr. Hinklin in the Powerline lab, all alone over here, taking that long walk to the front office, and think about those distances. So again, not about positives and negatives, distances. Okay, and that's why our absolute value, again, cannot be negative, because it's just a measure of our distance. All right, so that's all we got for this one. Again, any questions, let me know.